Okay, today we're going to start by continuing talking about how to sort things. And the idea is that when, well, think of how you sort something. If you had a bunch of cards with numbers on them and you wanted to sort them in increasing order, the usual, I mean, at some point, the basic operation you have is if you have two of them, you need to decide which one is bigger and which one is smaller. That's sort of the basic thing, and that's how all of the sorting algorithms work. You know, if I have two things, can I decide which one is bigger and which one is not? And now, in terms of logic, you need to make sure that that's consistent. So if I say that, you know, A is greater than B, then B has to be less than A. Kind of makes sense, but it is also possible to code things in such a way that that doesn't happen. So you need to be careful about that. And then the question comes up is that, well, what if you wanted to do it, what if you wanted to sort things a little bit differently than what is provided? So for example, the playing cards we sorted by the comparable interface is how you make instances of a class decide that. So you implement comparable, there's a compare to method, and the compare to method says, am I bigger than, less than, or equal to this other guy? But what if you wanted to do it differently? And then where it comes up with strings is that it turns out that the default implementation of comparable in the string, it does something which is almost what you want, but not quite in certain circumstances. We'll see what that's about. And then the answer to that is another interface called comparator. So there are two similarly named interfaces about this. There's the comparable interface, which you have a class implement if you want that instances of that to just be able to be put on one of these sorted set things. And then there's a comparator interface, which is a different interface which can allow you to change that. And then we'll start talking about maps, time permitting. Okay, so now, you know, just sort of the three basic things are strings are ordered lexicographically. You all know what that means? Are you familiar? Okay, you're on that. And what that does is that leads. Well, anyway, so you should also be able to write a custom comparator. I'll show you some examples of that, and then we're going to start talking about maps, which are not in the collections hierarchy, because a map is actually something a little different. Okay, so strings are a great example for this. So they do implement the comparable interface, and this lexicographic thing is based on, well, two things. You know, one is string length, and that's also something where we do it alphabetically, but here's where it's a little different than what you might think. So it's actually based upon the Unicode ordering of things. So weird symbols and numbers, for example, are less than, in the Unicode, they're less than the uppercase letters, and all uppercase letters are less than all lowercase letters. So what that means is that if I have a word that starts with capital Z and another word that starts with a lowercase a, then the capital Z comes before the lowercase a. So in this particular case, and then the other thing is that now numbers are treated as strings and not, you know, so the lexicographic ordering of a string representation of a number is a little bit, it's a little bit different. So, well, here it actually is that, but here Notice, okay, so if A, abacus, zygote, all there, and then small a and small abacus, that's lexicographic order. Okay? But if you're kind of, I mean, imagine you're kind of looking through something, and you're thinking alphabetically, and you know something is there and you can't find it. Why? Because you see the A's, but they're capital, and the small a's are kind of way out here. So alphabetically, you'd want to kind of do it this way. And now the string class actually has a comparator that sort of does it, but it doesn't do it the way you would want. So in this particular case, I want to have these separate. In other words, these are in a case-sensitive environment. These are two different things. If this is a Java program, and these are the names of things, then and they're in the same scope, these are two completely different things, because Java is case-sensitive. Okay, so how can we do that? So when the default string doesn't work. And yeah, 10 is less than 2 lexicographically. That's what I knew there was something there. Okay, so there's the comparator interface. So the comparator interface is something which you would write, and the interface only has one method, so it's actually a fairly lightweight thing. A class with one method and no instance variables. That's about as lightweight as you get. So if we want to sort things in an order different than their compare to method, then that's something we can do. On the other hand, supposing we wanted to sort things, but we're dealing with objects that don't implement comparable, then we can't actually put them on there. And that's actually what in my brain fart yesterday, what I forgot was the number class does not implement comparable. But what it does under the hood is because all of the subclasses do, it was kind of going to that. And so I'll show you how we can actually do what I should have done yesterday. But since we didn't know about comparators yesterday, I couldn't have done it, so I probably shouldn't have. All right, so if you remember, the comparable interface has a method called compare_to that just takes one argument. Why? Because that's an instance variable of the object that you're comparing to the other one. So all I need is I have this object and I'm comparing to the other object. Whereas an object that an instance of the comparator is separate from any of from the things that it's sorting, and so it has a single method called compare, and it has two arguments, so one and then the other. And so what compare does is it returns a negative number, typically -1, but it can be any negative number, if the first one is less than the second, meaning it's going to come first. It returns 1 or a positive number if the first comes after the second, and it returns 0 if the first is actually equal to the second. And it needs to be consistent, just as, remember, if equals had to be consistent, so if A equals B, then B must equal A. And likewise with the compare_to, if A compared to B is 1, then B compared to A must be -1. And similarly, if I compare the first to the second, then it should be the negative of compare the second to the first. Why? Because if the first is less than the second, it'll be negative, but that means that the second must be greater than the first, and vice versa. So, okay, some examples. Let me do the one that I screwed up yesterday first. Okay, so what I was trying to do was okay, we're still in here, so let's say mixed numbers. All right, let's see. Okay, number comparator. Okay, so what this is going to do, I'm going to write a comparator that's going to take any two numbers, and if I have two numbers, I don't care what type they are. So it could be double, float, long, int, short, what have you. But the numerical value, I can decide which is which, and that's how I'm going to do it. So my interface is going to be comparator. Oops. Comparator. And notice that the comparator is actually in the Java util class, whereas comparable is in the Java lang class. Okay, so implements comparator. We have a little red squiggly. It says not abstract. Oh, oops, I don't want a main method. And I can either, there's no point in making it abstract, implement all abstract method. Turns out that they give you a bunch of things, but I just want to do the compare thing. Okay. So I'm comparing, O1 to O2. Okay, I see what I did. See, now notice, I did it without the, without the generic. And then look what it gave me. It gave me objects. And, and now I could deal with that, but that means I would have to start casting them to numbers. I don't want that. I want type safety, which, okay, so it's going to deal with any number. And now when I implement the abstract method, it now puts the number in there. So the compiler does the cast for me. That's always safer, because the compiler is much smarter than I am. And then now here's the thing is that now as a number, I don't know whether this is an integer or a double, whatever, but all numbers have a double value they can get. And so I can say that if the O1 double value is less than the second double value, then I can return -1. Else, if O1 double value is bigger than the second double value, return 1, and if I get her, I'm going to return 0. Okay, because all numbers have this double value, so even if whether it's an int, short, long, I can get it as a double value, and then once I get it as a double value, I can compare them. And so, let's see, no red squigglies, I hope. Okay, now let's do a main. So these days I'll have to edit that. You can edit it. You can edit the template for these classes so it doesn't give you that nonsense, but I'm too lazy to do that. Okay, so this is what I was trying to do yesterday. Okay, so let's generate a bunch of random stuff. Okay, here's what I have to do differently. What I have to do is I have to, in the constructor, I can see what types of constructors we have. Well, there's sort of a weird syntax for dealing with generics that are subclasses of other generics, but we don't really, for our purposes, we don't need to get into that. I mean, if you're doing a deep dive in a lot of this, then that's something you might have to deal with at some point. But The point here is I instantiate my tree set and give it an instance of the number comparator. So the way that it works is that if I do the empty argument on the constructor, actually the comparator, it has an instance variable that's a comparator. If that's null, then it uses the compare to method of the comparable that you've put in it. And if it isn't null, if I've actually given it this, then it will use this instead of the one that's on the numbers. So how many? Oh, how many do I want? We don't need that many. I'll just do 5. And then let's do a Gaussian with a mean of 20 and a standard deviation of 5, say. Oops, yeah. And also let's do an int from like 40 to 50, maybe. And let's do one of these with an upper bound of 100, say. Okay, now notice it's letting me do that. And so now when I print that out, okay, so here, got it, what, 2, 5 point something. So notice that they're now more or less in sorted. They are in sorted order, but they're both integers, longs, and doubles on here. So this is how you do it with the numbers. All right. So now, what about strings? Okay, we knew. Well, actually, playing card is kind of the easier one. So let's do that. Let's do a let's call I wanted to do value first and interface comparator. Okay, so, and then I want to make sure to put the generic in. I would plain a card and card, and need to fix the imports on that, and then implement all abstract methods. And so for this, I want to first sort on the first one. So that's okay. Let's not do it that way. A better way is to actually use the fact that they are comparable. And then what do I do if I have, so in other words, if I have two, that the value of the first is less than the second or greater than, this will give me the result either way. The only catch is, what if I have like the 10 of spades and the 10 of hearts. So how do I, so if that's the case, then the result has come up 0. So I say if result is equal to 0, then result is equal to get suit compared to get suit. And I return. This is actually slightly better form than that's 0, then am I always, yeah, so this will be 0 if the suit and the value are exactly the same. Other than that, it's going to kind of do that. You know, how should I say? It's like, okay, here, what's slightly funky form about this, although it's sort of okay because it's so small, is that I have multiple return statements. That's slightly bad form. Here, this is better form because I only have one return statement at the very end. But, you know, if you do it this way, I'm not going to complain. But this is actually a slightly better way of doing it. Okay, so let's, yeah.
Couple questions on that. For the number comparator, can we just subtract the double values and return that, or can we just set it up so the larger number?
Oh yeah, great question. Yeah, that would be the only problem with that is that I need to return an int. And so if I'm subtracting two double values, and it comes in, let's say if it comes in less than 1, then it's going to it'll be like 0. So if so like 0.5 and 0.6, the difference is going to be 0. So yeah, but yeah, good point. Yes.
Is there like a function to like always round it up? So when you take the difference, you round up to the next highest end?
Yes, there is. It's called ceiling or seal. Yeah, that could probably work. Yeah.
Next question, Lester.
Sure.
Since we wrote the compare to function for playing card, will we use the comparator, or will we just go rewrite the compare to function where we use that before?
Well, that's kind of a design choice, but I mean, but at this point, in the process of development, this is like if we're developing an application. So here I wrote a class. I thought it was kind of perfect. Then I wanted to use it in a different context. And then I had to go back and I had to edit the class. In this case, to add the compare to method. And now I'm saying, okay, now I want to do it a little bit differently. But the thing is that having done it the other way, having written the compare to there, this is preferable because in order to change the other, in other words, there are two contexts in which I want to sort these objects. And I've already sort of made a choice. But I want to be as flexible as possible. So I want to actually do them both. So even if I go back and rewrite the compare to, and then sometime later I still want to do it the first way, then I'm going to have to write another comparator anyway.
Understood.
So, but again, that's, it's a bit of a, there's no hard and fast rule about that. But my hard and fast rule is if I've done something, there's no such thing as a trivial edit. In other words, once I have a class and it's working, I don't want to touch it. So in this context, my preference is once I get it and it's working in that context and there's a new context and I can do it without editing the original one, then that's always preferable. Where was I here? Okay, so let's test this out. Let's see, I had, where is it? Was it here? Yeah. Tell you what, let's just sort of be lazy and paste. Let's make this sorted set 3. Okay, so now, okay, this is the same as before, and so it's going to be first by suit, then by value. And so now, if I instead give it one of these guys, it's going to sort it according to, okay, so here are my ace, deuce, there are some 3s, 5, 6, 8, 9, and jack and queen. So there, in fact, what I'd want to do is, I have slightly different output now. Now, so one thing that's always kind of helpful in your 2-string, if it's short enough, if it's not a whole big thing, and then what this has done is okay. All right, so now the next little thing has to do with strings. So the thing is that, you know, sometimes lexicographic is fine, but if you know, like if you're looking for, let's say you have a directory with a bunch of files in it, and I'm looking for a particular one, and I have enough in there so that I can't see them all on one screen, on one little window. So I got to kind of scroll, and if they're alphabetical, then I can kind of easily find it. But if they're lexicographic, then it's a little harder, you know. So I want, you know, usually we want alphabetical, usually. And then the other thing is, is kind of what to do if I have two different words that are the same except for case, and that's a matter: is it case sensitive or case insensitive? The string class actually has a comparator that does it alphabetically, except it's case insensitive, meaning it will only have one of these on, and I want both of them. So how can I do that? And that's sort of the trickier one. And I had excuse me. I don't always get this right the first time, so you might have to bear with me. So okay, so alphabetic comparator. Oops, forgot to implement. And as we saw before, you always want to have the generic here. And it's another difference with the compare to. In almost every case, if I have a class that implements the comparable interface, the generic is always going to be the name of that class. Whereas a comparator is going to be, I get to choose the class, but you should always have a generic there. Otherwise, you'll have the method will have objects in it, and if you want to use any information about the class, you're then going to have to cast them. That's the way it used to be before they came up with generics, and basically it was just it just caused a lot of errors. Like any the optimal number of casts that you do in the code is 0. Now sometimes you have to, but if you don't have to, then don't. So just to kind of, especially for something that's going to be a little bit more complicated than this. Okay, now here's the thing. Okay, so here's the strategy. What I'm going to do is I'm going to first make them all the same case, and then see if they compare that way. If they don't, then I can simply return what happens on that. Okay, so let's make them uppercase. Oops. Okay, so what I'm going to say is that if let's see. Okay, if that isn't 0, then I can simply actually, got fat fingers today. Okay, so now I'm going to just say that's going to be my result. Now, if they are going to be different, then I can just I'm good basically. However, if they're not, then the result is equal to 0. So what do I do in that case? Well, in that case, what I need to do is here's where I need to kind of pull it apart and walk through character by character. So I can use this to-char array. Okay, now here's the thing. Here's the concern. This is that I have 2 arrays. Are they going to be, what if they're different sizes? What if they're different lengths? Because I need to walk through all the characters and start comparing them one at a time. Now, but here's the thing. If when I turn it to uppercase and the result comes in at 0, then the only way that can happen is if they have exactly the same number of characters and they're exactly the same up to case. So the only thing I need to check now is there a difference in case? And so, let's see. So because I know the lengths are going to be the same, I can just sort of pick one. You have to be a little careful. If I'm iterating, if I'm doing a loop over and I have 2 arrays, I have to worry about if they're different lengths. So if my upper limit is the smaller one, that means I might miss some information. If it's the bigger one, then I'm going to get array index out of bounds exceptions when I try to do it on the other one. But I'm safe here because the only way I can get to this point is if they're exactly as many. So I can just pick one. Yes?
So at this point, why can't we just use the compare to method if all we're looking for is a check case?
Because the compare to method will still do it lexicographically.
But if we know that if they're identical when you make them uppercase, wouldn't the compare to the only thing it lexicographically would detect as a difference in case?
You know, you might be right about that. Tell you what, let's see. But I might have been overthinking this. You know, you might absolutely be right. Okay, well, let's try it out. And that would be very, much cleaner than what I had in mind. All right, so let's all right, let's do this sort of a simple way. Let's just sort of do a bunch of things. Well, let's just to test it. Oops. That should be enough to. Okay, now. Okay, here's the, it would be nice if they had a constructor that gave you a comparator and another collection. It doesn't, so instead, there is an add all method. And I'll just add these guys in the list there and see how it worked. It looks like it worked. Let's sort of add some other stuff just to kind of make sure. Let me try these. It's another. And by God, you're right. Thank you. Okay, so the point there is that now you can you can. This is a really nice design, you know, and I think it's worth just sort of noting that what this does is it gives you the ability to have a default way of implementing something without having to do a lot of work. So if I'm fine, in this case, if I'm fine with strings being lexicographic, then I just use it. So I don't have to do a lot of work. If I want it a little bit differently, then I can actually do it, and I can do it in a simpler way than what I had in mind. I was wanted to kind of illustrate a little bit low, but this is okay. This is a much cleaner implementation of this than what I had in mind, but shows you how old school I am. What's nice about this I mean, that's as clean as the cleaner you can get, the better. It's not a matter of saving keystrokes. It's a matter of clarity. So this is, you know, it takes a little bit more reading, and would definitely want to have commenting on this. So, so the strategy is first compare without case. Compare. Then, if matches up to case, return the string compare to. You know, so just that if I see that and that's the strategy, then at least I know how it's doing it. So if it, and then when you look at the, you know, this may not be as sort of clear as possible. So in this, I'd want to say something like, you know, first make them uppercase, and then if not match, just and then you know, so on the one hand, you know, so you want to have a Java doc that at least explains what it does, and ideally maybe even, you know, even more with the best Java docs have like a usage thing, like here's how you use it, with some examples. And so you know, if somebody is coming across this and want to remember how to use it, especially if that somebody is you in a couple of months or something, then you know what's going on. Okay.
So,
Yes.
because this is a set, if the result returns as 0, does one of the elements get eliminated?
Yes.
Even though the two elements are not the same, we made them the same when we put the cover inside of this method, one of those elements was still eliminated because it returns 0.
Well, if this will be 0 only if these two strings have identical characters up to case. In other words, like in this case, for example, sort of this here we can actually sort of let's sort of step through it here. Let's see what we're okay. So here's okay. Here's it's comparing it with itself. So that's going to be 0 here. And then let's see what the next one is. Okay, so here's uppercase z and lowercase z. So when I compare them, that result is 0. But now the lexicographic is going to kick in. So in other words, the first criterion is if there's one letter that's different at all, then this will come up to a non-zero. The only way this comes up to 0 is if either they're exactly the same letters or the same letters except for case. And then if that's the case, then the lexicographic will distinguish them. Did that answer it, or?
Not quite.
Not quite.
I guess what I'm saying is, as you're building that sorted set, and it's sorting as you go, or as it sorts, if it says, for whatever comparison method we may use, that these are the same things, you're going to eliminate one, even though if you were to set like the actual element we're comparing, that zygote with the uppercase z, zygote with lowercase z, equals would come back false. But the way we're comparing, they're compared to be the same value. Does the sorted set recognize
Well, I mean, in this particular case, it hasn't, because there was one character that was different. If there's one character that's different, then lexicographic will distinguish it.
Yes, I think you had mentioned earlier that string has an inherent comparator that doesn't take case into account.
Correct.
So using that comparator, these would then return 0 because the case is the only difference. Would that cause one of those elements of my set to now disappear? I guess is what I-
Oh, yes, yes, it absolutely would. Tell you what, let's take a look at that. So instead, let's sort of override this. Okay, so now now I'm just using the default one. And the default one, notice I only have one A, one abacus, one M, and one zygote. Or I'm sorry, yeah, it distinguishes them. I'm sorry, it distinguishes them, but it puts these guys first. So
Is that just lexicographic?
yeah, yeah. So lexicographic will distinguish them if there's just one character difference. But none of them will. And this is, if I want to do, if I have two of these guys, neither one will duplicate that. So if I do it with mine, then it still only gives me one of these because the characters were exactly the same.
I think
Is that yeah? Yeah. So you want to if the characters are exactly the same, then the set won't allow a duplicate. Now, but what you're I think what you're touching on is that what constitutes a duplicate. And what constitutes a duplicate would be well. We're sort of out of time, but there is. Let's see, where is it? Where are you going here? There is sort of another one. Oops, I don't need that. But there's one called case-sensitive order. This is just one that string provides. And in that one, that's the one where it will not give duplicates based upon the case. So, and if that's what you want, then that's something that actually they kind of provide for you, and that's fairly straightforward to kind of do. So, okay, so that's it for this week. There's a holiday on Monday. There's not going to be another assignment, but the one that's outstanding is due next Tuesday. So I hope it doesn't ruin your weekend. But you should be able to get it done by Friday. Okay. So and we'll just have the lab tomorrow. We'll be working on the current assignment. So on Zoom.